Good morning. My name is Marlène Kiersnowski, and I'm the director of Tidal Energy Test Site at OpenSea Foundation. And I'm pleased today to discuss a bit about the SHINES project, which is about Tidal. So very happy to discuss Tidal today, especially in a context, as you may have heard in the past few hours and days, where in France we are expected big decision from our government. So we're hoping to bring our piece to the puzzle and to finally go towards commercialization with this technology. Let me briefly introduce who we are at OpenSea Foundation. We are the lead partner of this ambitious project. We are a foundation. Our status is a not-for-profit organization with general interest. We are a research infrastructure, kind of. We do operate 5 offshore test sites that focus on floating offshore wind and tidal and wave energy, as well as some floating PV projects ongoing. We've been created in March 2023. But our sites have a way longer time of existence. And our headquarters are in Nantes, but we are working across the Atlantic Ocean and Mediterranean Sea. The total project budget for this SHINES is a bit more than 10 million euros. It will last 4 years. It has officially started just a few months ago, so we are really starting the activities to some extent. It's funded by the Interreg Northwest Europe program. We've been awarded after the first call for project last year. And we do have quite a large and nice partnership. So we are 14 people, 14 different organizations across Northwest Europe working in that project. You can see the widespread geographical coverage of our consortium. We have pure players in the field of tidal energy. We've got also business support company, we've got SMEs, we've got universities working with us, and also some associated partners. Among them I can cite Ocean Energy Europe, who will be widespreading the result of our project. So what will we do? I hope next year I'll be able to present some of the results, the concrete result. Today I'm just gonna explain what we're going to do in the next few months and years. The objective for us is really to demonstrate the readiness of these technologies by deploying a number of technologies on real sea conditions, and have surrounding technical, environmental, and economic survey on performance, just to showcase how much this technology deserves to be included in our mix. We also want to enlarge a bit the vision of the market. We are, I believe, very much aware on the main areas where to develop tidal in France and Europe. We know France and the UK are the biggest markets, but for next generation devices, there are also other locations where project will be able to be developed. So our aim is to deliver an atlas of resource across Northwest Europe, and we really want to go to engaging something like 10 or more promising sites where we will undergo some site development activities and really engage with the local people working in these areas to make sure that goes along with local acceptance and supply chain development. At OpenSea and with the rest of the partners, we will mainly work on two or three pilot sites. Two of them are in France. So our focus will be on the Paimpol-Bréhat test site in northern Brittany. And we will also have some important activities in Bordeaux at SEANERGY, southwest France. And some development will occur also in Ameland, which is an island located in the province of Friesland in the Netherlands. So just a few words about these beautiful sites. Paimpol-Bréhat is a site that has been developed by EDF in 2012. I think the permits were obtained somewhere around 2012, 2014. This site is now operated by OpenSea for a bit more than 2 years now. It's 15 kilometers away from the coastline, so it has a very long cable route for a tidal energy project. The site can accommodate one grid-connected device. The depth is sufficient to have full-scale commercial device with 35 to 40 meter depth, and it's a very exposed area where the demonstration will experiment quite important waves condition. At SEANERGY test site, the conditions are really different. We are located in the heart of the city of Bordeaux with a current that goes in both directions. We've got flow and ebb. It's also a grid-connected test site for small-scale devices. And Ameland is a specific site nearby the area that has been developed and that is owned by Sea Currents. And Adele will talk a bit more about this site later on. Which solutions will we have a look at? 3 of them, mostly. We've got ORPC, Offshore Renewable Energy Corporation. This is a US-based company with headquarters in Ireland, and that's where that's the company we will work with. They will deploy a ReefGen device at SEANERGY in 2026 for 12 months and possibly more. They have more than 8 deployments already done, mostly in the US, Canada, and Chile. They have done the first deployment in Europe. The second one will be in Bordeaux. And then I will not talk too much about the other technologies because we have the chance to have the main players with us for this speech. So I will just give the floor to Adele to tell us more about Sea Current activities.
Thank you. Good morning. My name is... Whoa. There you go. My name is Adele Lamotte, and I support business development and marketing at Sea Currents. And I'm happy to be here today to talk to you guys about our Tidal Kite technology, which delivers 100% renewable energy 100% of the time. Oh wait, I have to go back. I don't think I have to explain to you guys why tidal energy is a positive thing. I think we're all pretty much on the same page, but we believe at Sea Current that the tidal kite can become a mainstream energy solution that can deliver 24/7 energy and complement the intermittent renewables that we have today. First, I'll quickly explain to you how the technology works. It's made up of different subsystems. So the main one is the tidal kite, which is the orange that you see up in the corner. And it's made up of various wings placed behind each other. And the flow direction, when it hits the wings, it makes the kite move in a perpendicular motion, and it flies in a figure 8 under the water. And this creates a traction for it through the tether, which is, that long cable, and then goes and gets transformed into electricity in the power takeoff, which is, the PTO, through hydraulics. And this has several advantages. One of which is what we call 3D harnessing, which you can see through this animation. So technically 3D harnessing means that because the wings are placed in this strategic position, the way that the kite flies makes that it can harness energy from multiple planes and sweeps a much larger surface area, which increases the energy yield significantly. And this widens the deployment potential as we can access sites that have much lower velocity currents. So in saying that, we can access sites that have lower velocity but also shallower waters, which means that we can capture energy from sites. We can significantly increase the tidal energy markets and have access to sites that were previously not accessible by other tidal technologies. There. And at SeaCurrent, we follow quite a structured approach. We've been in the water for quite some years already and are currently getting ready to head back to Amelon. So yeah, that's the blue dot on the map of the Netherlands, which is our test site. And we're getting ready to head back this summer and start our 4th sea trial. And the whole team has been working very hard the past couple of months to upgrade the kite and try and test it to be ready for the next testing period. And as part of the Shines project, we'll be deploying in Amelon, like I've said, the whole tidal kite system at our test site. So this is a fully permitted test site in a UNESCO World Heritage and Nature 2000 reserve, which is a testament to the eco-friendliness of the tidal kites. And we also continuously do monitoring and ecological research there to ensure that and reinforce the tie-in that we have with nature, as this is something that's very important to us. And we also work very closely with Amelon and the local community of Amelon. We've been working for many years with the Amelon municipality and the energy cooperative, which are also part of the Shines project. And they're front runners in the energy transition and in the local engagement. And to wrap this up, like Marlène said, we'll also be heading to Paimpol-Bréhat in France. The plan is 2027, but that may be up to change, to test in Brittany. And this is an amazing opportunity because this test site has much deeper water and faster velocity than our test site in Amelon, which means that, yeah, we can fine-tune the kite and test in a different environment, which is always positive. And we're also very happy to bring our own expertise in site mapping, site characterization, and in ecological monitoring. So we believe that the tidal kite it can play a crucial role in delivering predictable, clean, and locally sourced energy. And we're very happy to be part of projects like the Shines project and prove that tidal energy has a lot of potential and is scalable and can have an environmentally responsible source of energy. So yeah, thank you for listening, and then I'll pass the mic to Erwan for the other technology. And if you're as excited as us about tidal energy, then feel free to connect and get in touch with us. I think it's on already, or not.
Morning all. Thank you. I'm Erwan Nicolas. I'm technical manager at Inyanga. Inyanga is an innovative company developing cutting-edge solutions for the offshore renewable energy sector. Founded in 2018, an experienced team of offshore managers and design engineers. I work for Inyanga Tech, which is a French entity of Inyanga, incorporated in 2021, leading all EU-related activity for the group, representing around 60% of the turnover. Inyanga has two main businesses. The first one is hydrowing, which is a tidal technology which focuses on tidal technology, and Inyanga Maritime, which do offshore engineering and installation projects. So the competency we brought to Shines is a hydrowing solution based on tried and tested Tocardos turbines acquired in 2019 with 45 years of operation, unrivaled experience in tidal levers and export cable installation, maintenance and connection in Europe. We installed over 60% of all offshore tidal machines. And yes, offshore engineering and subsea structure design for main contractor in offshore in wind and tidal, as drilling, wet mate, mooring, and so on. So our patented technology hydroring, we have a twin turbine solution with a turbine T3 based on Tocardo technology, where we integrate power conversion. We added a passive pitch on the blades, 14 meter diameter and 600 kilowatts per device. Yes, a weight of 30 tons, and we can transport it in a 20 feet standard container. In the middle, we have a turbine transformer hub with a transformer which connects with the grid, and a power connection backpack based on a wet mate connector to connect to the export cable. And it all is modular and retrievable on very light solution, so that we don't have so much weight, and we can operate and retrieve the turbine with a standard vessel, much available on the market. So we have a multi-rotor subsea device, 60% lighter and efficient than existing tidal technology. Turbine mounted on a wing, like removal arm. Based on Tocardo technology, we developed a T3 solution with a 14 meter passive pitch, which is efficient, reliable, and proven turbine with 8 years of operation in Netherlands. We make some change on the initial solution with adding a gearbox and a flip solution that we get from Tocardo, but we added a passive pitch, which increased the yield by around 60%. Yes, no need for specialist offshore vessel and low-cost operation and maintenance with minimal downtime. Compact device for low-cost logistic and handling, fatigue-resistant substructure, and minimal environmental impact, which is, as we are seabed installed. We get a 20 megawatt project in Morlaix, located in Wales in the UK. This site is fully consented, grid connected. We get the first 10 megawatt with a CFD AR5 awarded in 2023, which represent 10 machines. We get a further 10 megawatts in AR6, in September 2024, which over 10 machines. This is connected with a single export cable with a subsea infrastructure. We are actually building the first demonstrator, which will be installed in 2026, next year. And the overall installation of the farm will be done in 2028, 2029. Our role in Shine is to design, construct, and install a 600 kilowatt hydroing device with a single turbine, grid connected in Brittany. We will operate it on monitor during 1 year, and yes, manage offshore operation for us and also for securing device. And based on our experience, we will participate to other tasks as market analysis, atlas of tidal resource, stakeholder engagement, and buyer data packs and supply chain capacity building. Thank you for listening.
Thank you very much. If you have additional questions, don't know if we have much time. We do have some time for questions, if you like. Yes?
Are there projects that take part in the Shine's program already defined, or you're looking for more?
The project is defined in terms of the consortium and the activities. Now we will have a number of activities that will need some procurement, some subcontracting activities. We will have especially buyers, meet the buyers event, where we would like to connect the supply chains with the turbine manufacturers in particular. We may have also some environmental studies, so you should stay tuned, because in the next few months we may effectively publish some opportunities depending on the sector you're working in.
Merci Marlène. Bonjour, je m'appelle Simon Formogier from the Offshore Renewable Energy Catapult. Erwan, can you tell us anything about the blades that Inyanga are using on the Tidal turbines? Because I think they're different from the original ones. Are you able to share a little bit of insight into the development that's gone on there?
Morning, Simon. Morning, Simon. Yeah, we changed the rotor because the initial hub was around 8 meters diameter. So now we have 14 meter. What we get from Tidal is a flip of the blade when the tide change of direction. So this was an initial solution, but we added a passive pitch, which is based on a spring, sort of spring. When the tide grow up, we can cut a little bit the power, not so much as a active pitch, but the main interest of that is we can get more power with this solution, and also have a reliable solution, because active pitch is difficult to maintain because we have a solution, subsea solution. So what we want is to have a very reliable solution. We didn't get as much how control as a active pitch, but with this one we can operate for 5 years without any problems, and keep more control and increase the power of the initial solutions. Yeah.
Thank you. I think it's time for us to wrap up. We do have some postcards if you want to go back home with a souvenir of a different site. Thank you very much.
Yeah.